Hello everyone, my name is Siddhartul Tanzila Tasmi, a student in the Department of Computer Science and Engineering from Islamic University of Technology. I would like to thank you all for your time. In this presentation, I look forward to presenting our paper titled PACTED, an artificially intelligent approach to detect pulmonary illness, pneumonia, asthma, COVID-19 and tuberculosis by myself and my team. Over the rest of the presentation, initially I'm going to talk about the research background, what interested us to selecting our topic, the methodologies that we have used in our research, and finally talk about the future applications to it. So, in recent decades, pulmonary disease and infections have been very common, and through the effects of the ongoing global pandemic caused by the coronavirus, people around the world globally are now concerned about these conditions. Pulmonary diseases are the categories of illness and infections that causes obstruction in the passage of airflow. The effects of these types of disease can vary from person to person, from causing minor obstruction to breathing to even critical life-threatening conditions. Today, chronic obstructive pulmonary disease is the third leading cause of death worldwide, affecting an estimated 384 million people and causing the death of 3 million people. Some of the pulmonary disease may be present from childhood, such as asthma, and some of them could be contagious, such as COVID-19 and tuberculosis. The most common causes of asthma includes having a genetic history of a parent having asthma, some allergic reactions, or chemical substance triggering it. A person living with such a condition may have to depend on an inhaler almost every day. Pneumonia, another lung disease, inflames the lung by producing a fluid inside it. It makes it very difficult to breathe for an infected person, and it not only affects the respiratory system but also the nervous system, the bones, and the abdomen. Symptoms include persistent cough for a few weeks, loss of appetite, sweating during the night, fever, tiredness. One of the most discussed topics in today's time is coronavirus. It is also an infected lung disease that has caused the death of at least 632 million people, causing a global pandemic that has immensely hampered medical financial sectors and has caused death to millions. The effect of COVID can either be mild symptoms to critical death conditions. Since it is an infectious disease that can contact through the respiratory droplet of an infected person, a person infected exposed to a patient can be easily affected by the disease. So pulmonary illness have been very common due to emerging viruses, pollutions, bacteria, and even our lifestyles. If these diseases are not diagnosed in a patient, they may have a severe impact and fatal condition in their life, along with a financial burden to survive in this state. Even if a patient can see external symptoms in himself regarding a disease, it can be very expensive to take all the available diagnostic tests. So, in this paper, we propose the application of machine learning algorithms in order to diagnose pulmonary disease. Machine learning models are efficient and effective in making crucial decisions to appropriate applications. In the case of medical field, the applications of these machine learning models can help make crucial decisions that can not only aid the medical workers but also save the patient's life from the deterioration that the disease can cause. In this research paper, common pulmonary diseases such as asthma, tuberculosis, COVID-19, and pneumonia can be detected based on just 9 symptoms using an artificial neural network, which has an accuracy of 99.305%. With this near perfect accuracy, diseases can be detected without any external cost as the implementation of machine learning usually do not require external heavy costs. So, how did we implement our whole research? Initially, we collected the publicly available data based on symptoms of the pulmonary diseases, which were cough, breathlessness, headache, mild fever, throat irritation, runny nose, etc. After that, we applied our data, which were processed into our machine learning models. The models were random forest, decision tree, gradient boosting, support vector machine, and artificial neural network. Finally, we put our other parameters that we tuned in our method. We did cross validation to evaluate our models and then evaluated our overall model through prediction on the unseen data, and then we drew different kinds of conclusions regarding their performance. So let us talk about the current researches based on these diseases. So in the first paper titled Deep Learning Based Respiratory Sound Analysis for Detection of Chronic Obstructive Diseases, a convoluted neural network has been applied for the detection of such diseases through respiratory sounds. The deep learning technique applied on this paper has an accuracy of 93%. The next paper, titled Diagnosing Asthma and Chronic Obstructive Pulmonary Disease with Machine Learning. Um, in this paper, the deep learning played a significant role in diagnosis by detecting COPD and asthma using machine learning. The primary model that was used in this paper was random forest that has detected COPD with a precision of 97.7% and in case of asthma with a precision of 83.3%. Deep learning approach was also used in another paper titled Lung Disease Detection Using Deep Learning. In this paper, uh, an X-ray dataset of infected people was used, and through this, the breathing problems have been identified with an accuracy of 89.77%. COPD was also diagnosed in the paper titled Machine Learning Methods for the Diagnosis of Chronic Obstructive Pulmonary Disease in Healthy Subjects, Retrospective Observational Cohort Study. In this paper, through 10 predictors such as smoking status, cough, allergic symptoms, and so on, machine learning algorithms such as gradient boosting was used as primary and logistic regression was used as a secondary method to detect the COPD and other diseases. The areas under the curve for the performance of these models were 95.6 and 94.3 respectively. The final paper titled uh, Explainable Deep Learning for Pulmonary Disease and Coronavirus Detection from X-rays. In this paper, it has addressed the better diagnostic using the said radiological imaging and evaluating the detection of the disease from said medical imaging. They use transfer learning, which is based on the deep learning method that in turn is a subset of machine learning. This method is primarily developed model to be used as a starting point for a secondary task. Adoption of deep learning detects the presence of COVID-19 by exploiting the transfer learning by showing the activation layers, that is, the areas in the chest X-rays considered generating the predictions. Three methods are adopted to detect from an X-ray related to a healthy patient or a patient with pulmonary disease to differentiate the disease. The models for discriminating between the healthy and the generic pulmonary disease obtains a sensitivity of 96% and specificity of 98%. The applied models have received incredible performance with the performance metrics, with the first model reaching an accuracy of 94% and the second reaching a performance with 98%. So this is the methodology and the working flow of our research. Initially, we collected the data which were pre-processed. After that, we statistically analyzed the data, then selected the different kinds of important features. After that, we divided our data into training and testing set into an 80 to 20 ratio. Tuned the important parameters for our research, and after that, we finally used our models which were random forest, decision trees, support vector machine, gradient boosting, and artificial network. And then we used cross validation for our model and then analyzed our performance through four parameters which were accuracy, precision, recall, and F1 score. So how did we use the datasets and pre-process the datasets? So the datasets used in our paper have been collected from two sites which were disease prediction using machine learning and machine learning based prediction of COVID-19 diagnosis based on symptoms. So in the first dataset, it dealt with detection of various diseases based on 132 symptoms. And in the second dataset, it deals detection of COVID-19 based on 5 general symptoms. The statistical distribution of the datasets were analyzed through Panda library. In the second dataset, the prognosis of a patient for being infected by COVID-19 has been studied based on symptoms. The dataset contained 5 common attributes that matched with the 5 attributes of the attributes required to identify pulmonary disease in my first dataset. However, the performance of the machine learning models decreased significantly with the removal of the four attributes. In order to deal with this condition, we randomize the data collected from the second data set, um, shuffle them with the first data set. After that, for the missing values, we used KNN impute, which dealt with the missing values for the rest of the four columns. This significantly increased the performance of the machine learning models. Since artificial neural network has given an accuracy of 99.3%, we can conclude that it can not only correctly identify the pulmonary diseases from the first dataset, but also from COVID-19 detection, which was integrated along with it. So these are the overall steps for our statistical analysis. Firstly, we used k nearest neighbor to deal with the missing values. Secondly, we standardized the features so that it is computationally faster to develop our models. It was done using the standard scalar library. Then we looked for our target features, which were the 9 attributes we used as symptoms, where the important features were understood through the relation of the dependent and independent variables with our target column using a correlation matrix. The correlation matrix of our paper has been given, where we can see the importance and the relation dependence of my symptoms such as cough, breathlessness, headache, mild fever, throat irritation, runny nose, etc. with my target column, which was prognosis. After selecting the models in the training set, we set up different parameters. So in this research paper, parameters have been optimized using random search CV. In this method, a random sample of variable is taken from a grid of given parameters, and the best parameters are given as output from the tested one. This is done as random search is relatively faster and computationally faster and can provide the best parameters in most cases. The following table shows the ideal parameters we have found from our respective models, which were for my 4 models. And afterwards, after training my dataset, we did cross validation while testing them. So cross validation is an ideal technique to validate the performance of the machine learning models. It is also called rotational estimation, where the whole dataset is divided into a certain number of folds. In this paper, the dataset was divided into 10 folds. Then, by rotation of one of the folds from the dataset is tested, while the rest is trained in cycles. In this way, all the folds of my dataset were eventually trained and tested, which does not make the overall machine learning model biased to perform well to a certain pattern. Each fold of the cross validation provides a set of performance for the output, and the final output of the machine learning model can be determined by analyzing the mean values for all the outputs of each fold. After that, we digged into our deep learning models. In this case, we have built our artificial neural network. Artificial neural network (ANN) is a popular deep learning model that functions similarly to the nervous system of the brain. It is formed from a collection of nodes similar to neurons and from a layer like the overall biological brain. Each node can send the signal to other nodes just like a synapse in the brain, while the signal signifies a real number. The output of each neuron is collected through a series of linear and nonlinear functions. In the neural network given here, the input layer had 9 nodes, while the output layer has 6 nodes, because the diseases were classified based on 6 outputs. And in the hidden 2 hidden layers were used, and in the hidden layers the categorical cross entropy was used as a loss function, and in the activation layer we have used for the input layer we have used ReLU function, and for the output layer and the hidden layer we have used the softmax function. The performance of the machine learning models used in our research were determined by 4 metrics, which were accuracy, precision, recall, and F1 score. After passing the parameters found through tuning, the algorithms they were passed into the 5 models. So the models were random forest, decision tree, support vector machine, gradient boosting classifier, and artificial neural network. And their performance, we analyzed them. The outcome of the machine learning models, as we can see through our chart, in case of random forest, the accuracy was 97.22, precision was 98.68, recall was 97.61, and F1 score was 97.53. In case of decision tree, it was 97.22 for accuracy, 97.82 for precision, recall had been 97.61, and F1 score was 97.53. The highest performance was observed for artificial neural network where the accuracy was nearly 99.305, precision was 100%, the recall was 99.3%, and F1 score was 99.5%. For based on that, the average mean values were taken, which were all kept 99%. The prognosis has been done accurately with an accuracy of 100%. So this is a remarkable achievement. However, the drawbacks of the working with 132 attributes for the first data set that we have used on our paper, which was detecting the diseases, was that it had 132 attributes. And first of all, it is very time consuming and straining for patients to answer their disease condition just based on symptoms like that. Secondly, patients answering the questions regarding the symptoms are prone to make mistakes regarding their health cases. Finally, the calculation of a disease prognosis with so many columns is computationally expensive, and not all medical workers or patients may have access to high level computers. Since pulmonary disease is one of the most common forms of illness worldwide, we have built our foundation in identifying this pulmonary disease with just 9 symptoms with an accuracy of 99%. So this is how we have enhanced our existing work. Artificial neural network is a deep learning model had only two hidden layers. That makes the network an overall simple architecture. It has a performance of 99.3%, which is remarkable. The model also has a perfect precision score. On the other hand, the rest of the applied machine learning models have a good performance of 97% estimated mean. Most of the applied machine learning algorithms have a similar accuracy level with only differentiating in the precision score. Among the rest of the algorithms, random forest and gradient boosting, which were the ensemble learning methods, have higher performance rate. The machine learning models have a nearly accurate accuracy, indicating that the probability of diagnosing the pulmonary disease by using machine learning algorithm and artificial intelligence is very high. This research can be further extended by scientists and further utilized to in disease diagnosis and making, which can be used in making crucial decision making. So finally, the architecture is very simple and it takes very less time to compute. So there is an overall fast computation speed, and this research can be easily available to everyone as the source code is available and anyone can implement the overall code and perform the analysis. So in conclusion, machine learning models are very efficient and effective in making those clinical decisions to appropriate applications. So in this case, we have made crucial medical decisions that can help the medical workers save the patient's life from the deterioration of this disease. One thing is that everyone can easily apply the models since the source code has been made public. And with this near perfect accuracy of the artificial neural network, pulmonary disease can be easily detected without any external cost. And machine learning algorithms usually do not require any fast computation as seen in this research. We are also working to develop a mobile application for easy access to everyone for this kind of diagnostic procedure. Besides this, machine learning models are very quick to respond and they don't usually deteriorate in functionality due to stress and load. This makes the performance of machine learning models usually more reliable. The application of this paper can also assist medical workers in making this medical decision and also recommend the appropriate diagnosis to a suspected patient. In terms of medical facilities, a patient does not usually require to perform multiple diagnostic tests, which saves the patient's money as well as the proper utilization of medical resources. Finally, through the application, anyone can have access to primary diagnostic for the disease for any time, anywhere. Uh, this can result in saving our lives of people overall globally in the world. So with all that said, I would like to conclude my presentation. Thank you everyone. Hope you all have a very good day.